Hello everyone. Let us now discuss how can we solve this problem. Count symmetric integers. So before going to this, let us see what is a symmetric integer. So integer x consisting of 2 into n digits. So first thing, x consists of 2 into n digits. That means the number of digits for that integer are even. 2 into n means every time it is an even digit count. If the sum of the first n digits of x is equal to the sum of the last n digits of x, then it is called a symmetric integer. And as they said, 2 into n and the first n and last n digits are equal, the sum is equal. So odd in number of digits are never symmetric. So we are given with two digits or integers, low and high. Return the number of symmetric integers in the range low, high. So let us do this problem by taking this example low and high. So what I'll do is taking a number 1, start with 1 and then 2 and then 3 till 9. But all these numbers are having only one digit. So 1 is an odd number. So I'll skip all this. Now if I go to 10, it is having even digits count, but first n digits and the sum of last n digits. The first n is just n value is 1 and the n value is 1. So here the first n digit sum is 1 and the last n digit sum is 0, and these two are not equal. So that's why we'll skip this and go to the next integer 11. So the sum of first n digits is 1 and the sum of last n digits is 1. So by this way 11 is considered as the integer, symmetric integer. So 11, 11 is the first one. Now wait a second. 11, 22, 33, 44, 55, 66, 77 and then 88, 99. So here after that if I go to 101, it is odd and also not in the range of low and high. It is exceeding 100. So the number of the count of integers which are symmetric is 9. Now let us look at 1200 to 1230. So if I write all those 12 and 12, right, and 1 2 1 3 and then 1 2 something like, let us see this as 0 3, right? 1 2 is having a sum of 3, last 1 2 is having a sum of 3, and they are in the range of low and high. Now 1 2 is having a sum of 3, 1 2 0 3 is having a sum, sorry, 0 3 is having a sum of 3, and before that let me write 1 2 2 1, right? So here I'll write like 1 2 1 2. Now 1 2 2 1 and then I am having 1 2 3 0, right? So there are four integers which are symmetric. So our answer is 4. Now what are we doing? What is the simplest way to do or solve this problem is, let me write algorithm. But before that let me write my approach. Approach is something like checking whether a number is symmetric or not by taking all digits in a vector, right? Checking the number is symmetric or not by taking all digits in a vector. This is my approach. So if sum of first n elements or digits, right, digits is equal to sum of sum of last n digits, that will increment our counter. So if I write the algorithm, first thing, count which I need to return at the end is initialized to 0. Now I'll write it from low till high. in the range. Even I have 1230 here. 1230 is also in the range. So low to high. If sum of first n digits and last n digits take digits in a vector and take sum 1 and sum 2. But when we are taking digits in a vector, let us take the total sum. And in the code, I wrote it as just sum. So total sum is took in the while taking the digits in a vector. So we no need to check two times, like first n digits and the last n digits for two times. Let us say sum 1 is till half the size of digits vector, but we'll do this only when if size of digits vector is even, right? Now I have another thing. Take someone is till half is the someone. Now I have if someone is equal to total sum minus sum 1, then total sum minus sum 1 is something like sum 2. So if I write it here, this is something like the total sum is 8. Now total sum is 8 and the first half sum is 4. Then what will be the next half sum? 8 minus 4. If I remove this portion from all this, if I remove this portion from all this, then I will get this portion sum. So sum 1 is equal to total sum minus sum 1. Then I'll increment the count, right? So at the last I'll return the count. But can we even optimize this? This is the code. But can we even optimize this? Here I took some half sum instead of sum 1, and here I have took sum instead of total sum. This is the change between the algorithm and the code. That's it. Now, can I even optimize this? Yes, I can use a string and get the sum, right? By converting converting the number into a string, right? Now let us see how can I change the code, right? I am taking a string. So I is equal to low, I is lesser than or equal to high, int n is equal to, so I am taking a string, right? Now string s, but instead of s, let me name it as n. N is equal to 2 string of I, right? I have the number into converted into a string. Now I need to iterate till the first half, and I need to iterate till uh, after the half. That means I need to take two halves, first half and last half. So if n dot size percentile 2 is, that means it is odd. If it is equal to 0, then I'll do something. For int j is equal to 0, j is less than n dot size by 2. That means I am going till half the size, and sum plus is equal to half sum, right? Int first half is equal to 0. First half sum, uh, right? First half first half plus is equal to s of j minus 0, and the second half sum. So I am changing here second half, and j is equal to n dot size by 2, and I am removing this condition. J is equal to n dot size by 2, and j is less than n. That means n dot size second half plus is equal to s of j minus 0. If first half is equal to second half, then increment the count, and I am returning the count at the end. So this is the first half. Let us see if we have any errors. So s of j, sorry, here it is n, that's the mistake. sorry for the mistake, n of j minus 0. Let us see, will it run? Yes, I have submitted the code. So this is how you solve this problem. And if you like this video, do share it to your friends and do subscribe to my channel. Thank you.